What if your phone could talk to space? Not through some clunky satellite phone from a spy movie, but your actual, everyday smartphone. What if no signal zones just disappeared? Whether you're hiking in a remote jungle, sailing in the middle of the ocean, or just stuck in a weird coverage gap on your commute. Well, this isn't science fiction anymore. This is the new frontier of non-terrestrial networks, or NTNs, and direct-to-device satellite communication. Today, we're diving deep into how your phone is becoming a space radio. We'll explore what these networks are, how they work, the incredible things they'll let us do, and the massive challenges we need to solve to make it all happen. So, what exactly are non-terrestrial networks? Think of them as extensions of our ground-based mobile networks, but in the sky. NTNs use platforms like satellites orbiting at different altitudes or even high-altitude drones and balloons to relay signals. The main goal? To bring connectivity to all the not spots on the planet, places where building cell towers is just too difficult or expensive. We're talking vast deserts, mountain ranges, and the open seas. The global standards body for mobile tech, 3GPP, has already started baking NTN support into the 5 rulebook, specifically in something called Release 17. But connecting to a satellite isn't the same as connecting to a cell tower down the street. For starters, many of these satellites are moving at incredible speeds, especially the ones in low Earth orbit, or LEO. This means the cell you're connected to is constantly moving, creating all sorts of technical headaches like Doppler shifts, that thing that makes an ambulance siren change pitch as it passes you. It also means your phone has to constantly switch between satellite beams, all while trying not to drop the connection. Then there's the distance. Even a low orbit is hundreds of kilometers up. This introduces significant signal delay, or latency, and your little phone has to shout its signal across that huge distance with its tiny battery. It's a massive engineering puzzle. This brings us to the most exciting part, satellite to cell, or what's often called direct-to-device. This is the magic trick of letting a standard, off-the-shelf smartphone talk directly to a satellite. No special equipment needed. How does it work? In simple terms, the satellite pretends to be a cell tower. From your phone's perspective, it's just connecting to another base station. But instead of the signal going to a tower on a hill, it's beaming up to space and then back down to a ground station connected to the internet. The latest 5G standards are starting to define how this works, using specific radio frequencies reserved for this purpose. At the same time, companies are getting creative with their own proprietary tech. Starlink, for example, is working with T-Mobile to make their satellites look like a standard T-Mobile cell tower to your existing phone. In the future, as we move towards 6G, phones will likely have this capability built right in, seamlessly switching between ground and space networks. So, what can you actually do with this? The most obvious use is for emergencies. Imagine being able to send an SOS text message with your location from anywhere on Earth, even with 0 bars of service. It's a literal lifesaver. This technology will also finally bring reliable connectivity to rural and remote communities, bridging the digital divide. For industries, it's a game changer for IT and asset tracking. Think about monitoring pipelines in the wilderness, tracking shipping containers across the ocean, or even following wildlife migrations, all without needing a nearby ground network. And for all of us, it means having a super reliable backup. If a natural disaster knocks out local cell towers, a satellite link could keep communications online. We're already seeing this happen. T-Mobile in the US recently expanded its satellite service, allowing popular apps like WhatsApp and Maps to work even when you're completely off the grid. Of course, making this all work smoothly is incredibly difficult. We already mentioned the Doppler effect from fast-moving satellites. The network has to constantly calculate and compensate for this frequency shift to keep the signal stable. Then there's latency. The time it takes for a signal to travel to space and back is much longer than on the ground. This makes real-time applications like voice calls or online gaming a serious challenge. Your phone's limited battery and transmission power are another huge hurdle. Engineers have to design incredibly sensitive receivers on the satellites and use clever techniques like beamforming to focus the signal, just so your phone's whisper can be heard from space. And the challenges don't stop there. As these satellites zip across the sky, your phone needs to perform seamless handovers from one satellite beam to the next, and even between the satellite network and the terrestrial one as you move back into coverage. This has to happen without you even noticing. Then there's the invisible traffic jam in the sky radio spectrum. These satellite networks need to find frequencies to operate on without interfering with existing ground-based mobile networks, TV broadcasts, or GPS. Getting global agreement on who can use what frequency, where, is a regulatory nightmare. Finally, for this to go mainstream, your phone needs the right hardware and software. This requires massive coordination between satellite companies, mobile operators, and phone manufacturers to ensure everything is standardized and interoperable. Despite the hurdles, the race is on. We have some major players making big moves. Link Global is building what they call cell towers in the sky, aiming to provide service directly to standard phones. AST SpaceMobile is another key competitor, partnering with major carriers like AT&T and Vodafone. And of course, there's the partnership between Starlink and T-Mobile, which is already delivering text messaging services in cellular dead zones across the United States. It's not just about phones either. IoT devices are also getting satellite-enabled, allowing them to report data from the most remote corners of the planet. These real-world deployments prove that direct-to-device is no longer just a concept on a whiteboard. So, what's next on the road ahead? Expect a gradual rollout. We'll start with basic services like emergency SOS, text messaging, and low-speed data for IoT. As the technology matures and more satellites are launched, we'll see capabilities expand to include voice and eventually, true mobile broadband. Future smartphones will increasingly come with NTN support as a standard feature. The holy grail will be a completely seamless user experience, where your device intelligently switches between terrestrial and satellite networks without you ever knowing the difference. This will likely require advanced AI to manage all the complexity behind the scenes. And perhaps most importantly, this technology holds the promise to connect the unconnected, allowing developing regions to leapfrog traditional infrastructure and join the digital world. In the end, satellites are no longer just a backup plan. They are becoming a fundamental part of our global communication fabric. By allowing our phones to connect directly to space, NTNs are poised to fill the final gaps in coverage, moving us closer to a world of truly ubiquitous connectivity. The path forward is filled with immense technical, financial, and regulatory challenges. But if we can solve them, we may finally see a day where the words "no service" become a distant memory, no matter where you are on the planet. Thanks for watching. If you found this journey to the edge of connectivity interesting, please give this video a thumbs up, subscribe to the channel, and hit that notification bell so you don't miss our next deep dive into the technology that is shaping our future. See you in the next one.